Most people spend a significant amount of time each day using mobile device keyboards, composing emails, texting, engaging in social media, and more. However, mobile keyboards are still cumbersome to handle. The average user is roughly 35% slower typing on a mobile device than on a physical keyboard. To change that, scientists developed brilliant language model for mobile device keyboards, working towards creating an intelligent mechanism that can enable faster input while offering suggestions and correcting mistakes. In any language the users choose. Behind the scene, the AI application was powered by an advanced language model. A language model is basically a probability distribution over words or word sequences. In practice, a language model gives the probability of a certain word sequence being valid. Validity in this context does not refer to grammatical validity at all. It means that it resembles how people speak, or to be more precise, how people write, which is what our language model learns. This is an important point. There is no magic to a language model, like other machine learning models, particularly deep neural networks. It is just a tool to incorporate abundant information in a concise manner that is reusable in an out-of-sample context. One major application for NLP is called machine translation. Machine translation is the task of automatically converting one natural language into another, preserving the meaning of the input text, and producing fluent text in the output language. While machine translation is one of the oldest subfields of artificial intelligence research, the recent shift towards large-scale empirical techniques has led to very significant improvements in translation quality. The best thing about machine translation is that it can translate large swaths of text in a very short time. Most of us were inoculated to machine translation when Google arose with the service. However, the belief has been over since the normal of the last century. Analysis work in machine translation, or MT, began as early as the 1950s, mainly in the United States. At its fundamental level, machine translation performs a straightforward replacement of atomic words in a single characteristic language for words in another. There are some different types of machine translation. The first is called Statistical Machine Translation, or SMT. It works by alluding to statistical models that depend on the investigation of huge volumes of bilingual content. It expects to decide the correspondence between a word from the source language and a word from the objective language. A genuine illustration of this is Google Translate. Although SMT is extraordinary for basic translation, its most disadvantage is that it doesn't factor in context, which implies translation can regularly be wrong, or we cannot expect great quality translation. The second is called Rule-Based Machine Translation, or Rbmp. It translates the basic of grammatical rules. It directs a grammatical examination of the source language and the objective language to create the translated sentence. Hybrid machine translation, as the term demonstrates, is a mix of Rbmp and SMT. It uses a translation memory, making it unquestionably more successful regarding quality. Nevertheless, HMT has a lot of downsides, the biggest of which is the requirement of enormous editing, and human translators will also be involved. The last technology is called neural machine translation. It is a type of machine translation that relies upon neural network models, which is mimicking human brain to build statistical models with the end goal of translation. The essential advantage of NMT is that it gives a solitary system that can be prepared to unravel the source and target text. Subsequently, it doesn't rely on specific systems that are regular to other machine translation systems, particularly SMT. NLP is a powerful tool with huge benefits, but there are still a number of natural language processing limitations and problems. The first problem is language ambiguity. Ambiguity in natural language processing refers to sentences and phrases that potentially have two or more possible interpretations. There are lexical ambiguity, semantic ambiguity, syntactic ambiguities. Even for humans, some sentences alone are difficult to interpret without the context of surrounding text. Part of speech tagging is one NLP solution that can help solve the problem to some extent. Synonyms is another potential challenge. It can lead to issues similar to contextual understanding because we use many different words to express the same idea. Furthermore, some of these words may convey exactly the same meaning, while some may be levels of complexities. And different people use synonyms to denote slightly different meanings within their personal vocabulary. So, for building NLP systems, it is important to include all of the word's possible meanings and all possible synonyms. Text analysis models may still occasionally make mistakes, but the more relevant training data they receive, the better they will be able to understand synonyms. The next is about contextual words and phrases and homonyms. The same words and phrases can have different meaning according to the context of the sentence and many words, especially in English, have the exact same pronunciation but totally different meaning. These are easy for humans to understand because we read the context of the sentence and we understand all of the different definitions. And our NLP language model may have learned all of the definitions. Differentiating between them in context can present problems. Misspelled or misused words can create problems for text analysis as well. Autocorrect and grammar correction applications can handle common mistakes, but don't always understand the writer's intention. With spoken language, mispronunciations, different accents, stutters can be difficult for a machine to understand. However, as language databases grow and smart assistants are trained by their individual users, these issues can be minimized. While natural language processing has its limitations, it still offers huge and wide-ranging benefit to any business. And with new techniques and new technology cropping up every day, many of these barriers will be broken through in the coming years.